Now in this lecture we'll find out the value of line segment X using three different methods. In the drawing we have a right triangle, triangle ABC is a right triangle, angle ABC equals to 90 degrees, angle DAC equals to 45 degrees, side AB of triangle ABC equals to 6 units, side DC equals to 10 units, and we want to find out the value of line segment A, or the length of line segment AD, that is equal to X. So we'll start with the first method, and here we will do a construction. We will extend line segment AD by a straight line, and then from point C we'll draw perpendicular to the extended AD. Okay, so here this angle equals to 90 degrees and this angle is equal to 90 degrees according to our construction. We will define the touching point of the perpendicular from point C and extended AD as point E. And here we created a right triangle, triangle AEC is a right triangle, and we will find out the value of this angle, that is actually angle ACA. What is the value of angle ACA? We know that the sum of the angles in any triangle is equal to 180 degrees, and especially the sum of the angles in the right triangle, triangle AEC, must be equal to 180 degrees. Therefore, which angles we have at the right triangle, triangle AEC? We have here 45 degrees, and we have here 90 degrees, and we have also angle ACE, that is the missing angle. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Here we'll subtract 135 degrees from this equation, and we get that the missing angle, angle ACE, is equal to 180 degrees minus 135 degrees, it is 45 degrees. So this angle equals to 45 degrees in its size, and we will define line segment DE as Y, therefore side AE of the right triangle AC equals to X plus Y, and in the right triangle AEC we have two angles that are equal to each other. Both those two angles, they are equal to 45 degrees, and we know that in front of equal angles of in the triangle there are equal sides. That is to say, according to the rule that I mentioned, side AE must be equal to side EC. AE must be equal to EC, according to the rule that in front of equal angles in the triangle there are equal sides. So AE equals to EC, but we have already found out that AE equals to X plus Y. So from this equation, X plus Y equals to AE equals to EC, we will derive that EC is also equals to x plus y. EC is equals to x plus y. Okay, so we found out that side EC of the right triangle AEC equals to x plus y, units in its length. Here, angle EDC is equal to angle ADB because of the fact that those two angles are defined as vertex angles, and vertex angles are equal to each other. So I will write it down. Angle, this angle that is actually angle ADB is equal to this angle that is actually angle EDC. And those two angles, they are equal to each other according to the rule that vertex angles are equal to each other. So if we define angle ADB as alpha, here angle ADB equals to alpha, then from this equation alpha equals to ADB equals to EDC, we derive that angle EDC is also equals to alpha. Angle ADC is also equals to alpha. So we can write down here that angle EDC equals to alpha. So in the right triangle EDC, this angle is equals to 90 degrees, so the sum of those two angles must be equal to 90 degrees because of the fact that the sum of the angles in any triangle is 180 degrees. So this angle must be equal to 90 degrees minus alpha in order to complete the sum of the angles in triangle EDC to 180 degrees. So 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. Likewise, from the same reason, this angle must be also equal to 90 degrees minus alpha. Therefore, we actually found out that the two right triangles, the two green right triangles, that is to say triangle ADB and the right triangle DEC, are similar to each other. Why they are similar to each other? Because of the fact that those two green right triangles, have exactly the same angles. Both those two angles, they are equal to 90 degrees minus alpha. Both those two angles, they are equal to alpha, and both those two angles, they are equal to 90 degrees. So I write it down. So in triangle ADB, the right triangle ADB, and the right triangle EDC, we have angle BAD. Angle BAD is equal to angle EDC, and both those two angle BAD is equal to angle ECD, and both those two angles, they are equal to 90 degrees minus alpha. I repeat again. Angle BAD is equal to angle ECD, and both those two angles, they are equal to 90 degrees minus alpha. Likewise, both those two angles, they are equal to each other and they are equal to alpha, so we can write down that angle ADB is equal to angle EDC, and both angles, they are equal to alpha. I repeat again. Angle ADB equals to angle EDC, and both angles are equal to alpha, and those two angles, they are also equal to each other, they are right angles. So angle ABD, the green right triangle, angle ABD is equal to angle DEC, this angle DEC, and both angles, they are equal to 90 degrees, they are right angles. Okay, I repeat again. Angle ABD equals to angle DEC, and both angles are equal to 90 degrees, they are both right angles. Therefore, we prove that all three angles in triangle ABD can point to all three angles in triangle DEC. That is to say, triangle ABD, the right angle triangle ABD, is similar. This is the sign of similar to triangle EDC according to angle similarity rule. And from the fact that the two green triangles are similar to each other, we will conclude that the following relationship exists between their sides. We will conclude that AB over EC is equal to BD over ED and it is also equal to AD over DC. I repeat again, from the fact that the two right triangles, triangle ABD is similar to the green triangle DEC, we will conclude that AB over EC equals to BD over ED, and it is equal to AD over DC. Okay? So this is equation number 1. AB equals to 6, so we substitute AB by 6. EC, EC equals to y according to our definition. No, EC, here EC equals to x plus y. So we substitute EC by x plus y, and it is equal to BD. We will leave it as it is, BD over ED. And ED equals to y according to our definition, and it is equal to AD. AD is x, so we substitute AD by x over DC. And DC equals to 10 according to what is given in the question. So we found out actually that according to the question number 1, 6 over x plus y equals to BD over y, that is equal to x over 10. We will find out the value of side BD according to, by implementing the Pythagoras theorem of the right green triangle, triangle ABD. In the right green triangle, according to triangle ABD, according to the Pythagoras theorem, here the letters PT is abbreviation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, x squared equals to 6 squared plus BD squared I'll repeat again. In the right triangle, triangle ABD, according to the Pythagoras theorem, x squared equals to 6 squared plus BD squared. We subtract 6 squared from this equation, and we get that BD squared equals to x squared minus 6 squared, that is minus 36. We will take a root out of this equation, and we will get that BD is equal to the square root of x squared minus 36. Okay? BD equals to square root of x squared minus 36. That is to say, we can substitute BD in equation number 1 by square root of x squared minus 36. We will do it now, and we will get that according to equation number 1, 6 over x plus y is equal to BD, and we've already found out that BD equals to the square root of x squared minus 36, BD over y, and it is equal to x over 10. So we found out that according to equation number 1, 6 over x plus y equals to square root of x squared minus 36 over y, that is equal to x over 10. Here we will create from this long equation 2 equations. The first equation that we will create with this equation, equation number 1, will be six over x plus y equals to x over 10 this side equals to this side, so 6 over x plus y equals to x over 10. So here we'll cross multiply equation number 1, and we will get that according to equation number 1, 6 times 10 is 60, and it is equal to x times x plus y. Here we'll open the brackets of this side of equation number 1, and we'll get that according to equation number 1, 60 equals to x times x is x squared plus xy. Here we will subtract x squared from this equation, equation number 1, and we will get that according to equation number 1, xy equals to 60 minus x squared. Okay, xy equals to 60 minus x squared. In the next step, we create equation number 2 for this equation. Those two sides are equal to each other. That is to say, square root of x squared minus 36 over y equals to x over 10. So this will be equation number 2. So according to equation number 2, we will get that the square root of x squared minus 36 over y, this is equation number 2, equals to x over 10 here we will cross multiply equation number 2, and we'll get that according to equation number 2, 10 times square root of x squared minus 36 is equal to xy. In the next step, we create a equation number 3 that states that xy according to equation number 1 must be equal to xy according to equation number 2. So xy according to equation number 1 equals to 60 minus x squared, and it must be equal to xy according to equation number 2, that is actually 10 times square root of x squared minus 36. Here we will square both sides of equation number 3, and we will get that according to equation number 3, 60 minus x squared squared, it is equal to 10 squared, that is 100, and here the square cancels the root, and what is left is it is only x squared minus 36. So here we will open the brackets on both sides of equation number 3, and we will get that 60 minus x squared equals to 60 squared, that is 3600, plus x squared, that is x to the power of 4, minus 2 times 60 times x squared, and it is equal to 100 times x squared, and 100 times minus 36, it is equal to minus 3600. So here we will add 3600 to this equation, equation number 3, and we will get that according to equation number 3, 3600 plus 3600 is 7200. That is equal to a plus x to the power of 4 minus 2 times minus 60 x squared is minus 120 x squared, and it is equal to 100 x squared. Here we will add 100 x squared to this equation, equation number 3, and we will subtract 100 x squared from this equation number 3, and we'll get that according to equation number 3, x to the power of 4 minus 120x squared minus 100x squared is minus 220x squared plus 7200 is equal to 0. Here we will substitute minus 220x squared by minus 180x squared minus 40x squared. And we'll get that according to equation number 3, x squared, and here minus 220x squared, it is equal to minus 180x squared minus 40x squared plus 7200 equals to 0. Here we take a common factor from these two expressions, and we will take also a common factor from these two expressions, and we will get that according to equation number 3, from these two expressions we will take a common factor of x squared. So what is left from x to the power of 4 after we took from it x squared as a common factor? What is left? This is actually x squared. And what is left from minus 180x squared after we took from it x squared as a common factor? What is left? It is actually minus 180. And from here we take minus 40 as a common factor from those two expressions. So what is left from minus 140x squared after we took from it minus 40 is a common factor? What is left? It is actually x squared. And what is left from 7200 after we took from it minus 40 is a common factor? What is left? It is actually minus 180. Why? Because minus 180 times minus 104 minus 180 minus 40, it is 7200, and all equals to 0. Here we can take x squared minus 180 as a common factor, and what is left from this expression after we took from it x squared as a common factor? What is left? It is actually x squared. And what is left from this expression after we took from it x squared minus 180 as a common factor? What is left? It is actually minus 40, and it is equal to 0. So here we will have two solutions that are possible for x. The first solution for x is that x minus 180 equals to 0, and the second solution for x is that x squared minus 40 equals to 0. So according to the first solution, we will get that x squared equals to 180. Here we will take a root out of this equation number 1, and we will get that according to equation number 1, x squared equals to before we take root, we know that 180 is equal to 36 times 5. Now we will take a root out of this equation number 1, and we will get that according to equation number 1, x is equal to the square root of 36 times 5. So x, according to equation number 1, is equal to the square root of 36 is 6 times square root of 5. So in conclusion, we found out that x is equal to 6 times square root of 5, and actually in terms of numbers, 6 times square root of 5, it is equal to 30.41 units. It is equal to 30.41 units. That is that is greater than 10 units. This is the first solution for x. And the second solution for x is that x squared equals to 40. Here we take a root out of this equation, equation number 2, and we get that x equals to the square root of 40. Forty is 4 times 10, and the square root of 4 is 2. So in conclusion, we found out that the second solution for x is that x equals to 2 times square root of 10, that is actually 6.32 units. So we have two solutions that are possible for x. And 6.32 units, it is less than 10 units. You will understand later why I wrote that 13.41 is greater than 10, and here 6.32 is less than 10. Okay? In the next step, I will copy the right triangle, triangle ABD, and the right triangle, triangle ADC in this new page. And we will analyze the two triangles in order to determine which solution is correct for x. Why? Because in the right triangle, in triangle ADC, in this triangle, triangle ADC, AD is equal to x. Here we will define angle BAD as theta, and angle ADB is equal to alpha. Here angle ADC, this angle is an exterior angle of the right green triangle, triangle ABD. I will repeat again. This angle, angle ADC, is an exterior angle of the right triangle, triangle ABD, the right green triangle, triangle ABD. Actually, the green right triangle, triangle ABD has 3 interior angles. The first interior angle is angle theta, the second interior angle is angle alpha, and the third interior angle is this angle that is equal to 90 degrees, and angle ADC is the exterior angle of the green right triangle, triangle ABD. And we have rule number 1 that is related to the size of an exterior angle. According to rule number 1, an exterior angle of a triangle is equal in its size to the sum of the two interior angles that are not adjacent to it. So I read rule number 1 again. According to rule number 1, an exterior angle of a triangle is equal in its size to the sum of the two interior angles that are not adjacent to it. So according to rule number 1, the size of the exterior angle ADC is an exterior angle to the right green triangle, triangle ABD, and the size of this exterior angle ADC, will be equal to the sum of the two interior angles that are not adjacent to it. Angle alpha is adjacent to angle ADC, and the two exterior angles that are not adjacent to angle ADC are angle theta and 90 degrees. And the sum of those two interior angles that are not adjacent to it equals to 90 degrees plus theta. Okay, so we found out, in conclusion, that the size of angle ADC equals to 90 degrees plus theta. And we also know, it is given us the question, that angle DAC equals to 45 degrees. And the sum of the angles in any triangle is equal to 180 degrees. So if you focus on triangle ADC, then in triangle ADC, the sum of the angles must be equal to 180 degrees. This triangle ADC. So which angles we have in triangle ADC? We have here one angle that is equal to 45 degrees. This angle. The second angle is angle ADC that is equal to 90 degrees plus theta. And we have also this angle that is actually angle ACD. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So here we subtract 135 degrees from this equation, and we will get that theta plus angle ACD is equal to 180 degrees minus 135 degrees. It is equal to 45 degrees. Here we will subtract theta from this equation, and we will get that the angle that we are looking for, angle ACD, the missing angle is equal to 45 degrees minus theta. Okay, angle ACD equals to 45 degrees minus theta. So we can write down here that this angle equals to 45 degrees minus theta. And from the drawing, you can see it is very easy to see too, that this angle is the smallest angle in triangle ADC. So I write it down. Angle ACD, that is equal to 45 degrees minus theta, is the smallest angle in triangle ACD. Okay? And from the fact, and we know that it is given us the question that side DC equals to 10 units, and because of the fact that this angle is the smallest angle in triangle ACD, we can conclude something about triangle ADC after I present to you the second rule. According to rule number 2, the smallest angle in the triangle is always in front of the shortest side. I'll repeat on rule number 2 again. According to rule number 2, the smallest angle in the triangle is always in front of the shortest side. So here we know that angle 45 degrees minus theta is the smallest angle in triangle ADC. Therefore, according to rule number 2, it is in front of the shortest side. That is to say, AD that is equal to X is the shortest side. AD that is equal to X is the shortest side. In triangle ADC. AD that is equal to X is the shortest side in triangle ADC. And we know that DC equals to 10 units. That is to say, X is less than 10 units. Because X is the shortest side, it means that in triangle ADC, it means that X is less than 10 units. Okay, we can conclude from it that X must be less than 10 units because of the fact that it is the shortest side in triangle ADC, and we have one side that is equal to 10 units, therefore it must be less than 10 units. So, according to our conclusion, we found out that X must be less than 10 units, but have we have two answers for x. According to the first answer, we found out that x is equal to x is equal to 5 x is equal to 6 times square root of 5. 6 times square root of 5, that is 13.41, and 13.41 is greater than 10. So, according to this answer, x is greater than 10, but we found out that x must be less than 10 units. Therefore, this solution is incorrect solution. We cancel this solution, and we left only with the solution that x equals to 2 times square root of 10. It is actually equals to 6.32 units, that is less than 10. So this is the only solution that we have here, that the value of x, that is AD, it is equal to 2 times square root of 10, that is actually 6.32 units. So the answer to the question is that x equals to either 2 times square root of 10 units or 6.32 units. We finished with the first method. In the next step, I will present to you how to find out the value of line segment x according to the second method. In the second method, we will do another construction. From point D, we'll draw a straight line to AC in such a way that the angle that will be created will be equal to 45 degrees. Here, angle AED is equal to 45 degrees according to our construction. Okay? So, in triangle ADE, we have two angles that are equal to each other, and according to the rule that in front of equal angles in the triangle there are equal sides, we get that AD is equal to ED. AD equals to ED. But AD equals to x according to what is given in the question. So from this equation, x equals to AD equals to ED, we will derive that ED is also equals to x. ED is also equals to x. In the next step, we'll define angle BAD as theta. If angle BAD equals to theta, then angle ADB must be equal to 90 degrees minus theta. I already explained to you that the sum of the angles in the triangle must be equal to 180 degrees. So here theta plus 90 degrees minus theta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the reason that this angle must be equal to 90 degrees minus theta. Okay, and we also know that the sum of the angles in any triangle in the world must be equal to 180 degrees, and especially in triangle AD, the sum of its angles must be equal to 180 degrees. So which angles we have in the right triangle, in triangle ADE? We have here 45 degrees plus 45 degrees plus this angle, that is angle ADE. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles must be, in a triangle must be equal to 180 degrees. So 45 degrees plus 45 degrees is 90 degrees. We will subtract 90 degrees from this equation. So here 90 degrees will get cancelled, and 180 degrees minus 90 degrees, it is 90 degrees. So we found out that the missing angle, angle ADE, equals to 90 degrees. Angle AD equals to 90 degrees. It is given us the question that ABC is a right triangle, therefore BC is one side of the right triangle, triangle ABC, therefore it is absolutely a straight line. We can write down that BC is a straight line. BC is a straight line. We have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BC at point D, then the sum of the angles must be equal to 180 degrees. So which angles we have on the upper side of BC at point D? We have here one angle that is equal to 90 degrees minus theta. We have this angle that is equal to 90 degrees. And we have also the missing angle, angle ADC, EDC, this angle. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that I mentioned, that the sum of the angles on one side of a straight line must be equal to 180 degrees. So here 90 degrees plus 90 degrees is 180 degrees, so we have 180 degrees from both sides of the equation, so 180 degrees will get cancelled, and we're left only with minus theta plus angle EDC, that is equal to 0. Here we will add theta to this equation, and we'll get that the missing angle, angle EDC, is equal to theta. Okay, we found out that this angle equals to theta. In the next step, we'll make another construction. From point E, we will draw perpendicular on BC. Okay, from point E, we will draw perpendicular on BC. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees, and we will define the touching point of the perpendicular from point E and BC as F. So actually, triangle EFD, this triangle is a right triangle. And because of the fact that this right triangle, this angle angle EDF is equal to theta, then this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right triangle to 180 degrees. Okay? In the next step, we will prove that those two right green triangles congruent to each other. Why those two right green triangles congruent to each other? First of all, we focus on the right triangle ABD. And the right triangle EDF. First of all, those two angles, they are equal to each other, they are both equal to theta. So angle BAD is equal to angle EDF, this angle, and both angles are equal to theta. I'll repeat again, angle BAD equals to angle EDF equals to theta. AD equals to DE equals to X. AD equals to DE, and both sides are equal to X. And we also have those two angles that are both equal to 90 degrees minus theta. Therefore, they are equal to each other. So, angle ADB is equal to angle EDF, and both angles are equal to 90 degrees minus theta. So we actually proved that those two green right triangles can go into each other according to angle side angle rule. We have those two angles. Those two angles are equal to each other, those two angles are equal to each other, and the side that attached to them are also equal to each other. AD equals to DE equals to X. So we can write down that triangle ADB congruent, this is the sign of congruent, to triangle EDF according to angle side angle rule. And from the fact that those two triangles can go into each other, we will conclude hence AB is equal to DF. AB equal to DF. AB is equal to DF according to the rule that corresponding sides in congruent triangles are equal to each other. Those two green triangles can go into each other, therefore the corresponding sides, that is to say AB and DF, must be also equal to each other. But we know it is given us the equation that AB equals to 6. So from this equation 6 equals to AB equals to DF, we will derive that DF is also equal to 6 units. DF is also equal to 6 units. And what is the value of FC? It is very easy to see from the drawing that FC is equal to FC equals to DC minus DF. Again, DC minus DF equals to FC. So FC is equal to DC, that is 10 units, minus DF, that is 6 units. 10 minus 6 is 4, so we found out that FC equals to 4 units. FC equals to 4 units. We can write here that FC is equal to 4 units. Likewise, because of the fact that those two triangles can go into each other, we will conclude that BD equals to EF. BD is equal to EF according to the rule that corresponding sides in congruent triangles are equal to each other. And if we define BD as Y, so BD is equal to Y according to our definition. So from this equation, Y equals to BD equals to EF, we conclude that EF is also equals to Y. EF is also equals to Y. In the next step, we will prove that the right triangle ABC is similar to the right small triangle EFC. I repeat again. We will prove that the right triangle ABC is similar to the right triangle EFC. Why those two triangles are similar to each other? First of all, we know that those two angles, they are equal to each other, they are both right angles. So angle ABC is equal to angle EFC, and both angles are right angles, they are equal to 90 degrees. We also know that this angle is a common angle, it belongs to both triangles, so we can write down that angle ACB is equal to angle ECF, and because they're equal to each other, it is a common angle. It is a common angle. And those two angles, they are also equal to each other. So angle BAC, this angle, this is actually equal to theta plus 45 degrees, is equal to angle FAC, and those two angles are equal to each other according to third angle theorem. Third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent because they are complementary to 180 degrees. So we actually proved that all three angles in triangle ABC congruent to all three angles in triangle EFC. Therefore, we actually proved that triangle ABC is similar. This is the sign of similar to triangle EFC according to angle similarity rule. Okay? And from the fact that triangle ABC is similar to triangle EFC, we will derive that AB over BC is equal to EF over FC. Okay? I will repeat again, from the fact that triangle ABC is similar to triangle EFC, we will conclude that AB over BC equals to EF over FC. So AB is 6, so we will substitute AB by 6. BC is equal to Y plus 10. You can see it easily from the drawing. That side BC, this side BC of triangle ABC equals to Y plus 10 units. And it is equal to EF. EF is Y over FC. FC is 4. So actually, in conclusion, we found out that according to equation number 1, 6 over Y plus 10 equals to Y over 4. Here we will cross multiply equation number 1. And we will get that 6 times 4 is 24. And it is equal to Y times Y plus 10. We will open the brackets on this side of equation number 1, and we will get that according to equation number 1, 24 equals to Y times Y is Y squared. Y times 10 is 10Y. We will subtract 24 from this equation number 1, and we will get that according to equation number 1, Y squared plus 10Y minus 24 equals to 0. So we got a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of a quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X, it is actually equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay. In our specific quadratic equation, the coefficient a is equal to 1, the coefficient b is equal to 10, and the coefficient c is equal to minus 24. And the variable that we are looking for is y, so x is equal to y. So we'll put the data inside the formula for x, and we'll find out the value of the values of y, because x is equal to y. So we'll get it according to this equation. Y equals to minus b. B is 10, so minus b is minus 10, plus minus square root of b squared. B is 10, so b squared is 10 squared, that is 100, plus minus 4 times a is 1, times c is minus 24, over 2a. A is 1, so 2a is 2 times 1, that is 2. So we got that y equals to minus 10 plus minus 4 times minus 24 is plus 26, and minus 4 times minus 24 is plus 96, and 96 plus 100 is 196 over 2. So here y is equal to minus 10 plus minus. The square root of 196 is 14 over 2. So here we will have two solutions that are possible for y. The first solution for y is y1 is equal to minus 10 minus 14 over 2. Minus 10 minus 14 is minus 24 over 2 is minus 12. So we found out that y1 equals to minus 12 units. But because of the fact that y is the length of a side of a triangle, it must be a positive number. Y, it is a length, therefore it must be a positive number. Therefore this solution that y equals to minus 12 is the correct solution. We cancel this solution, and the second solution that is left, y2, it is actually equals to minus 10 plus 14 over 2. Minus 10 plus 14 is 4. 4 over 2 is 2. So we found out that the second solution for the quadratic equation y2 equals to 2 units. So here we can write down that y equals to 2 units. So I will copy the right triangle ABD in this new page, and we will implement the Pythagoras theorem on the right triangle, triangle ABD. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is x, so x squared equals to 6 squared, that is 36, plus 2 squared, that is 4. So x squared equals to 36 plus 4 is 40. And we take a root out of this equation, and we get that x equals to the square root of 40. 40 is 4 times 10. The square root of 4 is 2. So in conclusion, we found out that the value of x, that is actually line segment AD, it is equal to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. So we finished with the second method. In the next step, I will present to you how to find out the value of line segment x according to the third method. In the first method, we will define angle BAD as theta, and side BD will be defined as y. So here we know that in the right triangle, triangle ABD, in this right triangle, tangent theta equals to y over 6 Now we will focus on the right triangle, triangle ABD. On the right triangle, triangle ABD, this will be question number 1. Tangents 45 degrees plus theta is equal to y plus 10 over 6. And we have the trigonometric identity for tangents 45 degrees plus theta. Tangents 45 degrees plus theta is equal to 1 plus tangents theta over 1 minus tangents theta. We will use this trigonometric identity and we will substitute in equation number 1 tangents 45 degrees plus theta by this expression. And we get that according to equation number 1, here tangents 45 degrees plus theta equals to 1 plus tangents theta over 1 minus tangents theta, and it is equal to, according to equation number 1, to y plus 10 over 6. Y plus 10 over 6. Here we have already found out that tangents theta equals to y over 6, so we substitute tangents theta in this equation, equation number 1, by y over 6, and we get that according to equation number 1, 1 plus tangents theta is y over 6 over 1 minus tangents theta, it is also y over 6, and it is equal to y plus 10 over 6. Here we will multiply 1 by 6 and then we divide it by 6 in order to have a common factor with y over 6 and with minus y over 6. And you will get that according to equation number 1, 6 plus y over 6 over 6 minus y over 6 equals to y plus 10 over 6. Here we have 6 in the numerator and 6 in the denominator, so 6 will get cancelled. What is left from equation number 1 after we cancel 6? What is left is actually 6 plus y over 6 minus y equals to y plus 10 over 6. Here we will cross multiply this equation, equation number 1, and you will get that according to equation number 1, 6 times 6 plus y equals to 6 minus y times y plus 10. We will open the brackets on both sides of equation number 1 and we will get that according to equation number 1, 6 times 6 is 36 plus 6y equals to 6y (6 times 10 is 60) minus y times y is minus y squared, and minus y times 10 is minus 10y. Here we have 6y on both sides of the equation, so 6y will get cancelled. What is left from equation number 1 after we cancelled 6y? In this side of the equation we have 36 is equal to 60 minus y squared minus 10y. So we will add y squared and also 10y to this equation, equation number 1, and we will get that according to equation number 1, y squared plus 10y And we will also subtract 60 from this equation, equation number 1, and we get that 36 minus 60 is minus 24, that is equal to 0. So we have the same quadratic equation as we had in the second method, and the solution to this quadratic equation, y squared plus 10y minus 24 equals to 0, it has two solutions. The first solution is y equals to minus 12, but because of the fact that y is the length of side BD of triangle ABD, it must be a positive number. Therefore, the negative y cannot be equal to minus 12. So we cancel this solution and we left only with the second solution that y equals to 2 units. So here we know that y equals to 2 units. So I'll copy the right triangle, triangle ABD in the new page, and we'll implement the Pythagoras theorem on the right triangle, triangle ABD. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. So x squared plus 6 squared, x squared equals to the square of the hypotenuse is x squared, and it is equal to the sum of the squares of the perpendiculars. That is to say, it equals to 6 squared, that is 36, plus 2 squared, that is 4. So x squared equals to 36 plus 4, that is 40. We take a root out of this equation and we get that x equals to the square root of 40. So x equals to 40 is 4 times 10. So x equals to 2 times square root of 10 units. Or in terms of numbers, it equals to 6.32 units. This is the answer to the question. Now I will summarize the lecture. We start with the first method. So actually in the first method we have here right triangle ABC. This angle equals to 45 degrees, side AB equals to 6 units, side DC equals to 10 units, and we want to find out the value of line segment AD, that is x. In order to find out the value of x, we made a construction. We extended the line segment AD by a straight line, and then from point C we drew perpendicular to the extended AD. So this angle equals to 90 degrees and this angle also equals to 90 degrees. We define the touching point from the perpendicular from C, and the extended AD is point E. And here we have in the right triangle, triangle AEC, we know that the sum of the angles must be equal to 180 degrees. So which angles we have in the right triangle, triangle AEC? We have one angle that is equal to 45 degrees, we have one angle that is equal to 90 degrees, and we have the missing angle that is actually angle ACE. In total, the sum of those three angles must be equal to 180 degrees. So we subtracted 135 degrees from this equation, and we got that the missing angle, angle ACE, equals to 180 degrees minus 135 degrees. It is equal to 45 degrees. So in the right triangle, triangle AEC, we have two equal angles, and we know the rule that in front of equal angles in the triangle, there are equal sides. that is to say, AE must be also equal to EC, because those two sides are located in front equal angles. So AE is equal to EC, and we define DE as Y. So AE equals to X plus Y. So we can write here that AE equals to X plus Y. So we have the equation from the equation XY equals to A equals to EC. We will derive that EC is also equals to X plus Y. Okay? Then those two angles, they are equal to each other because they are vertex angles, and we have the rule that vertex angles are equal to each other. So we define one angle as alpha, then the other angle must be also equal to alpha. If angle ADB equals to alpha, then angle ADC must be also equal to alpha because of the fact that they are equal to each other. So in the right triangle ABD, the right green triangle, this angle equals to alpha, so this angle must be equal to 90 degrees minus alpha. Here also in the right triangle EDC, the right green triangle, this angle equals to alpha, so this angle must be equal to 90 degrees minus alpha. Okay? Then we proved that those two right green triangles are similar to each other. Why they are similar to each other? First of all, those two angles are equal to each other. They are both equal to alpha. Those two angles, they are also equal to each other. They are equal to 90 degrees minus alpha. And those two angles, they are both right angles. They are equal to each other. So we proved that all the angles in triangle ABD can go into all the angles in triangle EDC. Therefore, we proved that those two right angles can go into each other, are similar to each other according to angle similarity rule. Triangle ABD is similar to triangle EDC according to angle similarity rule. And from the fact that those two right green triangles are similar to each other, we will conclude that AB over EC is equal to BD over DE, and it is equal to AD over DC. I'll repeat again. We conclude that AB over EC equals to BD over ED equals to AD over DC. AB equals to 6, EC equals to X plus Y, BD equals to BD, and ED equals to Y, AD equals to X, and DC equals to 10. Then we found out the value of BD by implementing the Pythagoras theorem on the right green triangle ABD. From the drawing you can see that according to the Pythagoras theorem, x squared equals to AB squared plus BD squared. Okay? That is to say, x squared equals to 6 squared plus dB squared. We subtracted 6 squared from this equation. We found out that BD squared equals to x squared minus 36. We took out of this equation and we found out that BD equals to the square root of x minus 36. So we can substitute BD in this equation by square root of x squared minus 36. We did it, and we got that according to equation number 1, 6 over x plus y equals to BD, that is square root of x squared minus 36 over y, and it is equal to x over 10. Okay? So from this long equation, we derived two equations. The first equation is 6 over x plus y equals to x over 10. Here, this side equals to this side. Here we cross multiply this equation number 1, and we got that 6 times 10 is 60, and it is equal to x times x plus y. We open the brackets in this side of the equation, and we got that 6 equals to x times x, that is x squared, plus xy. We subtracted x squared from this equation, and we got that x squared, according to equation number 1, equals to 60 minus xy. Then we created the second equation. From this equation, you can see from this equation that this side of the equation equals to this side. So this side of the equation equals to this side. So square root of x squared minus 36 over y equals to x over 10. Okay, here square root of x squared minus 36 over y equals to x over 10. We first multiply this equation number 2, and we got that 10 times square root of x squared minus 36 equals to xy. Then we created equation number 3 that states that xy according to equation number 1 must be equal to xy according to equation number 2. xy according to equation number 1 is 60 minus x squared, and it must be equal to xy that according to equation number 2 that is actually x times square root of x squared minus 36. Okay, then we squared both sides of equation number 3, and we got that 60 minus x squared equals to 10 squared, that is 100, and the square cancels the root, and we left only with x squared minus 36. So in conclusion, according to equation number 3, we got that 60 minus x squared equals to 100 times x minus 36. 6 minus x squared is equal to 60 squared. 60 minus x squared equals to 60 squared, that is 3600, plus x squared, that is x to the power of 4, minus 2 times 60 times x squared. And it is equal to 100 times x squared, and 100 times minus 36 is minus 3600. Okay, then we added 3600 to this equation number 3. 3600 plus 4600 is 7200, plus x to the power of 4 minus 60 times minus 2x squared is minus 120 times x squared, and it is equal to 100 x squared. We subtracted x squared from this equation, and we got that x squared minus 120 x squared minus 100 x squared is minus 220 x squared, plus 7200 equals to 0. Then we substituted minus 220 x squared by minus 180 x squared minus 40 x squared, and we got this expression that x to the power of 4 minus 180 x squared minus 40 x squared plus 7200 equals to 0. So we took a common factor of x squared from those two expressions. So inside the brackets we have from this expression what is left is x squared, and from this expression what is left is minus 180. After we took from it x squared as a common factor. Then we took from those two expressions minus 40 as a common factor, and here what is left from minus 40x squared, after we took from it minus 40 as a common factor, what is left is actually x squared. What is left from 7200 after we took from it minus 40 as a common factor, what is left is minus 180, because minus 40 times minus 180 is 7200. So here we got this equation, and we took x squared minus 180 as a common factor out of this expression, and here what is left from this expression after we took from it x squared minus 180 as a common factor, what is left is actually x squared. And what is left from this expression after we took from it x squared minus 180 as a common factor, what is left, it is actually minus 40. So in conclusion we got that x squared minus 180 times x squared minus 40 equals to 0. So here we have two solutions that are possible for x. The first solution for x is x squared minus 180 equals to 0, and the second solution is that x squared minus 40 equals to 0. According to the first solution, x squared equals to 180, but x squared 180 is 36 times 5, so we took a root from this equation, and we found out that x equals to the square root of 36 times 5, and the square root of 36 is 6, so inside the root we left only with 5. So in conclusion, we found out that according to the first solution, x equals to 6 times square root of 5, that is actually 13.41 units, that is bigger than 10 units. In the second solution, according to the second solution, x squared minus 40 equals to 0, that is to say x squared equals to x squared minus 40 equals to 0, so that is to say x squared equals to 40. We took a root out of this equation number 2, and we got that x equals to the square root of 40. 40 is 4 times 10, and the square root of 4 is 2, so in conclusion we found out that according to the second solution, x equals to 2 times square root of 10, that is actually 6.32 units, that is less than 10 units. Then I copied the right triangle ABD and the triangle ADC in this new page, and here we have angle ADC is an external angle of triangle ABD. Okay, and triangle ABD is 3 interior angles that are theta, alpha, and 90 degrees. Okay. So here we have rule number 1 about the size of an external angle. An external angle of a triangle is equal in its size to the sum of the two interior angles that are not adjacent to it. So here the size of this external angle, angle ADC is an external angle of triangle ADB. The size of this angle, the external angle ADC, will be equal to the sum of the two interior angles of triangle ABD that are not adjacent to it. Angle alpha is adjacent to angle ADC, and the two other angles that are not adjacent to it is theta and 90 degrees. So in conclusion, the size of the external angle ADC will be equal to theta plus 90 degrees, or 90 degrees plus theta. And we know that this angle equals to 45 degrees, and this is the missing angle. And we know that the sum of the angles in any triangle, and especially in triangle ADC, must be equal to 180 degrees. So here, we found out actually that the size of this angle is equal to 180 degrees minus 45 degrees minus 90 degrees minus theta. So the size of this angle, it is actually equals to 45 degrees minus theta. Okay. And we have actually all here angle ADC, the missing angle here, equals to 45 degrees plus 90 degrees plus theta, plus this is the missing angle, that is angle ACD. In total, the sum of those three angles must be equal to 180 degrees in triangle ADC. We subtracted 135 degrees from this equation, and we got that theta plus angle ACD, the missing angle, equals to 180 degrees minus 135 degrees is 45 degrees. We subtracted theta from this equation, and we found out that the missing angle, angle ACD, equals to 45 degrees minus theta. So you can see from the drawing that this angle, angle ACD, that is equal to 45 degrees minus theta, is the smallest angle in triangle ADC. Angle ACD, that is equal to 45 degrees minus theta, is the smallest angle in triangle ADC. Okay? And we have also rule number 2. According to rule number 2, the smallest angle in the triangle is always in front of the shortest side. So according to rule number 2, this smallest angle must be in front of the shortest side. That is to say, AD that is equal to X is the shortest side in triangle ADC. That is to say, X is less than 10 units. Okay? AD equals to X is the shortest side in triangle ADC according to rule number 2. That is to say, X is less than 10 units because it is less than this side DC of triangle ADC that is equal to 10 units. So it is the shortest angle, therefore it must be less than this side that is equal to 10 units. So X is less than 10 units, and we had 2 solutions for X. The first solution is X equals to 6 times square root of 5 units, that is 13.41 units. Here X is bigger than 10 units, but X must be less than 10 units, according to what we have already found out. Therefore, this solution is incorrect solution, and we left only with the solution that X equals to 2 times square root of 10, that is actually 6.32 units, that is less than 10 units. So the answer to the question is that the value of the length of side line segment X, that is AD, is 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. If we finish with the first method, then I show to you how to find out the value of angle X according to the second method. In the second method, we made another construction. From point D, we drew a straight line on AC in such a way that angle AEC will be equal to 45 degrees. So in triangle ADE, we have 2 angles that are both equal to 45 degrees, and we have the rule that in front of equal angles in the triangle there are equal sides. That is to say, in front of those 2 equal angles there are equal sides. That is to say, AD must be equal to DE. AD must be equal to ED, but AD equals to X. So from this equation, X equals to AD equals to ED, we will derive that ED is also equals to X. Okay? And we know that the sum of the angles in the right triangle ADE must be equal to 180 degrees. So which angles we have in the right triangle ADE? In this right triangle, we have 45 degrees plus 45 degrees, plus this is the missing angle, angle ADE. In total, the sum of those 3 angles must be equal to 180 degrees. 45 degrees plus 45 degrees is 90 degrees. We subtracted 90 degrees from this equation, and we got that the missing angle, angle ADE, equals to 180 degrees minus 90 degrees, that is 90 degrees. So we found out that this is a right angle, therefore triangle ADE is a right triangle. Okay? So this angle equals to 90 degrees. We defined angle BAD as theta. If angle BAD equals to theta in the right triangle ABD, then this angle must be equal to 90 degrees minus theta. So this angle equals to 90 degrees minus theta. This angle equals to 90 degrees, and this is the missing angle. And we know that ABC is a right triangle. Triangle ABC is a right triangle. That is to say, BC is one side of a triangle. Therefore, it must be a straight line. BC is a side of a triangle, must be a straight line, so BC is a straight line. And we have the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So if we focus on the upper side of the straight line BC at point D, then on the upper side of BC at point D, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned 1 minute ago. And so which angles we have here? At point D, we have one angle that is 90 degrees minus theta. We have this angle that is 90 degrees, and we have the missing angle that is angle EDF. In total, the sum of those two angles must be equal to 180 degrees. I repeat again, one angle that is 90 degrees minus theta at point D, plus the other angle that is right angle, it is equal to 90 degrees, plus the first angle that is angle EDC. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So here we have 90 degrees plus 90 degrees is 180 degrees, so we have 180 degrees on both sides of the equation, so 180 degrees will get cancelled, and we left only with minus theta plus angle EDC equals to 0. We added theta to this equation and found out that the missing angle EDC equals to theta. This is the missing angle that is equal to theta. Okay, so if this angle equals to theta, but before that, this angle equals to theta, then we made another construction from point D. We go perpendicular on BC, so this angle equals to 90 degrees, and this angle will also equals to 90 degrees. So we created the right triangle, triangle DEF. In this right triangle, this angle equals to 90 degrees, and this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right triangle to 180 degrees. So then we proved that those two right green triangles can go into each other. Why those two right green triangles can go into each other? First of all, those two angles, they are equal to each other, they are both equal to theta. We have side AD that is equal to side DE that is equal to x. And we have those two angles, they are equal to each other, they are both equal to 90 degrees minus theta. Therefore, triangle ADB is going to go into triangle EDF according to angle side angle rule. We have those two angles and the side between them can go in correspondingly to those two angles and the side between them in the other triangle. Therefore, those two triangles can go into each other according to angle side angle rule. And from the fact that those two triangles can go into each other, we will conclude that AB is equal to DF. AB is equal to DF according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, those two green triangles can go into each other, therefore the corresponding sides, that is to say AB and DF, will be equal to each other. So AB equals to DF, but AB equals to 6, it is given us in the question. So AB equals to 6, so, and from this equation 6 equals to AB equals to DF, we will derive that DF is also equal to 6 units. If DF is also equal to 6 units, likewise, because of the fact that those two green triangles can go into each other, we will conclude that BD equals to EF. BD equals to EF, and if we define BD as Y, then from this equation Y equals to BD equals to EF, we will derive that EF is also equals to Y. EF is also equals to Y. And what is the value of line segment EF? From the drawing it is very easy to see that EF equals to EC equals to DC minus DF. Again, DC minus DF equals to EC. Okay? Again, FC equals to DC minus DF. FC equals to DC minus DF. DC equals to 10, DF equals to 6, so FC equals to 10 minus 6, that is 4. So we found out that FC equals to 4 units. And here we also know that EF equals to Y. Then we proved that the right triangle ABC is similar to the right small triangle EFC. why those two triangles are similar to each other. First of all, they have two right angles. Therefore, those two right angles are equal to each other, and they have also common angle. This angle is a common angle, it belongs to both triangles, and those two angles must be also equal to each other according to third angle theorem. What is third angle theorem? Third angle theorem is that if two angles in one triangle is congruent to two angles in another triangle, then the third pair of angles must be also congruent because of the fact that they are complementary to 180 degrees. So those two angles also equal to each other. So we actually proved that all the angles in triangle ABC can go into all the angles on triangle EFC. Therefore, we proved that triangle ABC is similar to triangle EFC according to angle similarity rule. And from the fact that the right triangles are similar to each other, we will derive that AB over BC equals to EF over FC. AB over BC equals to EF over FC. AB equals to 6, BC equals to Y plus 10, EF equals to Y, and FC equals to 4. So in conclusion, found that according to equation number 1, 6 over Y plus 10 equals to Y over 4. We also multiplied equation number 1 and we found out that 4 times 6, that is 24, equals to Y times Y plus 10. We open the brackets on this side of equation number 1 and we got that 24 equals to Y times Y, that is Y squared, plus Y times 10, that is 10Y. We subtracted 24 from this equation and we got that Y squared plus 10Y minus 24 equals to 0. So here we have a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. A, B, C are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, a equals to 1, b equals to 10, and c equals to minus 24. And the variable that we are looking for is y, so x equals to y. So we'll put the data inside the equation for x, and we'll find out the value of the values of y. Y equals to minus b, b is 10, so minus b is minus 10, plus minus square root of b squared, b is 10, so b squared is 10 squared, that is 100, minus 4 times a is 1, c is minus 24, minus 4 times minus 24 is 96, 96 plus 100 is 96, and the square root of 196 is 14. So in conclusion, we found out that y equals to minus 10 plus minus 14 over 2. We have two solutions that are possible for y. The first solution is y equals to minus 10 minus 14 over 2. Minus 10 minus 14 is minus 24. Minus 24 over 2 is minus 12. But because of the fact that y is a length, it must be a positive number. Therefore, y equals to minus 12 is the correct answer, is the correct solution. And we're left only with the solution, the second solution, that y equals to minus 10 plus 14 over 2. Minus 10 plus 14 is 4, 4 over 2 is 2. So here we found out that BD equals to 2, AB equals to 6, it is given us that in the question, so AD is the hypotenuse in the right triangle ABD. According to the Pythagoras theorem, x squared equals to 6 squared plus 2 squared. X squared equals to 6 squared, this is 36 plus 2 squared, this is 4. 36 plus 4 is 40. We took a root, so x squared equals to 40. We took a root of this equation, and we found out that x equals to square root of 40. That is to say, x equals to either 10 times square root of 10, 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. We finished with the second method. In the next step, I will present to you how we found out the value of line segment x according to the first method. In the first method, we defined this angle as theta and side BD as y. In the right triangle ABD, triangle theta equals to y over 6. Then in the right triangle ABD, triangle is 45 degrees, plus theta equals to y plus 10 over 6. Okay, and we have the trigonometric identity that tangents 45 degrees plus theta equals to 1 plus tangent theta over 1 minus tangent theta. So we substituted tangent 45 degrees plus theta in equation number 1 by this expression, and we got that according to equation number 1, 1 plus tangent theta over 1 minus tangent theta equals to 1 plus 10 over 6. Then we have already found out that tangent theta equals to y over 6, so we can substitute tangent theta by y over 6. We did it, and we got that according to equation number 1, 1 plus y over 6 over 1 minus y over 6 equals to y plus 10 over 6. Here we multiplied 1 by 6, and then we divided by 6 in order to have a common factor with y over 6 and minus y over 6, and we got that 6 plus y over 6 over 6 minus y over 6 equals to y plus 10 over 6. We have 6 in the numerator and 6 in the denominator, so 6 will get cancelled. And after we cancel 6, we left with 6 plus y over 6 minus y equals to y plus 10 over 6. We of course multiplied this equation, equation number 1, and we got that 6 times 6 plus y equals to 6 minus y times y plus 10. We open the brackets on both sides of the equation, so 6 times 6 is 36. 6 times y is 6y, 6 times y is 6y, 6 times 10 is 60, minus y times minus y is minus y squared, and minus y times 10 is minus 10y. We have 6y on both sides of the equation, so 6y will get cancelled. We added, so in conclusion, we found out that 36 equals to 60 minus y squared minus 10y. We added y squared and also 10y to this equation, equation number 1, and we got that y squared plus 10y equals to, we subtracted also 60 from this equation, and 36 minus 60 is minus 24, so we got to the quadratic equation that y squared plus 10y minus 24 equals to 0. We have already found out in the second method the solution to this quadratic equation. The first solution was y equals to minus 12. But because of the fact that y is length, it must be a positive number, so this solution is incorrect solution because y is negative, and we left only with the solution that y equals to 2 units. And so here y equals to 2 units, bd equals to y that is equal to 2 units, ab equals to 6 units, it is given as the equation, and the hypotenuse ad equals to x. We implemented the Pythagoras theorem on this right triangle, triangle ABD. According to the Pythagoras theorem, x squared equals to ab squared, that is 6 squared, that is 36, plus bd squared, that is 2 squared, that is 4. So x squared equals to 36 plus 4, that is 40. X squared equals to 40. We took out of this equation and found out that x equals to the square root of 40. The square root of 40 is 2 times square root of 10 units. So the length of line segment AD, that is x, is equal to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, thank you very much.